Hey everyone. Let me get set up right now. Doing full screen to start. But yeah, let me just get everything all set. How do people like the shirt? I have a blue one and a green one, both Deep ML. Let me finish getting set up and then I will get started. Where I edit this. Sorry. Okay, let's try this again. Should get everything set up shortly. Okay, there we go. I forgot my AirPods. I usually like to listen to music while I'm streaming. But I guess at some point I might run and get them, but for now. Okay, there we go. Okay. Welcome everyone. So let me hide these. Okay. Switch to this view. Am I even moving though? I don't think so. Okay. Darn it. Did this just freeze? This is what I get for trying to be fancy with stuff. Oh well, now you have tech support stream. Give me a second. Let me just hide this for now. You can look at my frozen face. Let's see if I could just. Oops, that works. Let's just. Delete this one. It's like you don't need me that big. That looks okay. Okay. And we're back. One of these days I'll get really good at this, but for now, you have my subpar editing. So today, I want to build my own optimizer. I know I said, I guess in previous things, I wanted to go through all of the current optimizers, go through stochastic gradient descent, momentum, blah, 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 all of them. But I think it'd be more fun just to try and build something myself based on my current understanding of, optimizers. And we'll try and hopefully become the #1 spot. If not, I mean, we're pretty good. Top 56%. Got so that time I'm pretty sure we just did a simple, I don't know, we messed with the learning rate basically. We took like the mean gradient plus an amount over the current learning rate, whatever. But our goal will be to create our own optimizer. I feel like it's pretty cool. Let's see. One idea. I had this a while ago. I never tested it out. No. Just work as I want you to work. Okay. One idea I had at some point was, okay, so imagine we have, this is our loss land field, and we're here. I was thinking, let's say, we took a step in either direction, either this way. I'll zoom in. Try and see if I could. Let's just rerun this. There we go. That's a lot. Is it crisper? Yeah, okay, that's a lot crisper. So you could take a step here, or you could take a step here, and that will, that's gradient descent, and you go down eventually until you get here. So at some point I was thinking, what if we just did, like, we take a random step, left or right, that's our first step, and then we would just take the probability, we would take the percentage difference. So theoretically, if this goes here, and let's say I took a random step and it went down, say the value went down 50%. So the next step would be 50% and so on. So you start with random. So let's write this out. An idea for, so start with random. Start with a random step. Instead of getting the gradient, I guess we're getting get percent change. Get percent change. And then update the weights. Did not update that. Okay, fine. Update the weights. So this is something I thought about, and I was like, why can't we just do percent change? Why are we doing gradients and things like that? So I'm gonna try and implement this and see how it goes. So let me just take this. I'll go here. Do I have the two of the same things? I do have two of the same things. I don't need this one open. I'll try to zoom in more. I noticed last time I didn't zoom in so much. We have this, and we will grab the first test case just to play around with. So we're given grad and we're given params. Yes, I know NumPy was already made. Just okay. So our goal is to I don't know if we could do this, but let's think. Because I guess here we're only given the parameters, which I guess are the weights, and we're given the gradients. And I guess for my process we would need to, why does it keep, we would need to get the loss and then do it. Yeah, I guess for my process where I wanted it to be, why is it ugly? Let's try to rerun this one last time. Okay. There we go. So I want it here. This, it's going to complain that I don't have the code. Okay. So my first idea was to do it based on okay. First idea was to do it based on, instead of gradients, I guess it's giving me the gradient values, so I can't really do this. So was to do it based on percent changes in the loss. So you take a step, you see both the percent changes, and you move the parameters that much, but I guess we can't really do that right here. We're sort of constrained to having gradients. I like using the gradients because we don't have the actual predictions, we just have the parameters of the model. And okay, so let's try something else. Probably should figure out how states work, but we're going to. What would be something cool we could do with, what would make sense for us? So this is optimization, and usually we look at all the grads and we make steps. I'm thinking, what if we let's say instead of moving it based on the gradient like we currently do, you move it based on the max gradient. So np.max. So instead of looking at everything, we're just like, hey, whatever the highest value is, move it based on that. And let's say the learning rate would be 0.01. But then I guess we'd want a case where, because I guess, what's the ideal situation? We're given a loss and we're able to get down pretty quick. And once we get down, we should do smaller steps to get the exact answer. But you want to get down to a solid loss before anything else. I'm trying to think. I feel like, so you would want this max grad thing to work when the learning rate, or I guess you want the max to work. Okay, let's just try it with the max and we'll see how it does. Learning rate we'll leave at 0.01. Here we'll do, let's start here. Validate. I probably should have run it first and see if it actually works. Alright. Oh, on Twitter we're having a, any second now, we're having a, I'm trying to determine what we should do for the next giveaway. So right now it's Very Deep Network seems to be winning, followed by Network from Scratch, and that all these. Why did it break? Oh my goodness! Open. Is this thing down again? You had this. Alright. Yeah, okay. I'm gonna need to change the way we do this because this is just annoying. It keeps on breaking. That's so annoying. I was really excited for this. It's the whole 5 days ago. Yeah, okay. You're gonna have to switch off of OpenML. Let's go with, I don't know, I'm trying to think about it because I know I want to test it out. See if I could just have chat just make me a quick. It's even working. Yeah, hassle. That's probably not going to work out well. It's so annoying. Yeah, I guess that's the issue with having dependencies on other people's things is sometimes it breaks and you know you get screwed because of it. Is it working? Are we streaming on X? Here we are. Okay, let's go with plan B. I don't know what plan B is because I really wanted to do this. It was working for what, 4 days and then stopped working again. Let's just solve the daily question. Okay, reinforcement learning stuff. Reinforcement learning stuff is always fun. Maybe now the title of the video is a lie, but whatever. Let's get started. Algorithm that performs one step of value iterations given a Markov decision process, MDP, using Bellman equation. The function should update the state value function, VFS, for each state based on possible actions, transition, probabilities, rewards, discount, okay, blah, blah, blah. Only use NumPy, coolies. Okay, so we are given this. NumPy is already cool. And I'm assuming Bellman's thing is not ready either, so here. So we are given transition, these values, I'm assuming that's for 1 and that's for 2, but let's figure out what those actually are. For state 0, I'm assuming that's state 0, state 1, state 0, state 1? I don't know. State 0, best action is to go with state 1. Let's see if I have it here. There we go. Sorry, let me zoom in, zoom out. I need a better method of zooming in. This just doesn't work nicely. Oh wait, I think I do. Okay. So given V, state values, transition, list of dictionaries, transitions from S to A, list of probabilities, next state, reward, and done or not. So transitions, so 0. What is it? Probability, next state, reward. I'm just trying to understand what the transition is. Like, what does this mean? Let's see if we could. Okay, Belmont update. List of dicts. Yeah. I said dicts. I said dictionaries. um. Let's see. Let's try and understand transactions. Yeah, that's pretty cool. Prints it out quite nicely. Okay, so I guess we have transitions, not transactions, two transactions. So we have one, and this is given two possibilities, and each one list of probability, next state, reward, and done. So if you get to 0, you stay at 0 and you don't win, seems like. If you get to 1, you also stay there and you get a reward. Oh, what's the next state? Your next state is 1. Okay, let's run this. I want to see what other transitions. Need to add more test cases to this. This one looks more fun. Transitions. Hold on. I'll be right back. There we go. Okay. And I got my music. Okay. Where were we? Let's go gamma. New V, but I'm assuming the LS we don't have right now. Okay. So now we have a transition. Is this not? There we go. Transitions. Transitions? Let's just see. Okay, that makes more sense. So let's draw this out. This transition environment. So given 0, and we're given, these are different states. So you're given state 1 and you're given state 0. You could go from 0 to 1, so that's here with 0.2 probability. And you could go to yourself. Oh. Go to yourself with probability 0.8. So at each state you have those probabilities. And then we'll talk about rewards later. Then if you're in state 1, it's funny how it doesn't say its terminal states as false for that, but basically it says with probability probability 1, you're going back into this one, so you'd stay in 1 forever. Confused by why we have 2 transitions. Like there's just 2 different states we could choose from. Because this would look like that second one, so this would be our first one. And the second one would look like, should just copy this. Just copy this. This just looks like one. Alright, yeah. So if you're in state 0, you stay in state 0. If you're in state 1, you stay in state 1. But I think this last column right here is, let me make sure. Pretty sure this last column is the reward. So reward and then done, the second last thing. So if you stay in state 5, if you stay in, let's say case 1, you do this 0.8 route, you get green. You get +5. If you do this transition, you get +10. And then you're in state 1 forever, getting +2. So, or here you get +0. So I guess if you maybe just needs to choose which of these routes to go on, so I'd probably go with route 1 all of the time. Yeah, so that's the current view of the transitions. So let's try and see Belmont's update. this. Copy this. Let me know if everyone could see properly, if I should zoom in. Right Okay, so let's get into what the Belmont equation actually is. It's a recursive equation in reinforcement learning that relates the value of the state to the value of the possible next state. It provides mathematical foundation for key RL algorithms such as value, iteration, and Q-learning. Coolsies. Key idea. For each state S, for each state S, are we given states even? Just given, okay. For each state S, the value V of S is the maximum expected return obtained by choosing the best action A, and then following the optimal policy. So V of S is the value of state S. It's the maximum probability state prime. Okay. So this basically, let's break this down a little more. Let's first understand everything. A, possible actions. Probability of S prime, so the next stage in S, given your current state. Okay. No, I don't. I do not want this. That's the probability of so if you're in state 0, the probability of going to state 1 given, yeah, so what's the probability of going to state 1 given that you're in state this and you took a specific action. So if you took this action, because this is one action, this is one action, so the probability of going to state 1 given you're here and you took the action this is 0.2. This is the reward you get from going from this state, taking this action and going to the next state. So it's RSAS. Discount factor, so assuming that discounts, we'll get to it. V prime of S, the value of the next state. I really had my heart set on the optimization stuff. Well, this is also good and valuable, just like, I wanted to build something new and cool. Yeah, but the dependency we have broke, so we need to redo how we have to reinvent how we do it. I'm not in the mood to do this as much. I feel like when we get to labs for RL, we could do stuff, do something pretty cool there. I feel like we could, give you a little environment and see how your RL agent is doing. I'm not in the mood to solve this right now. Maybe I'll solve it later. I wanted to work on my own optimizer. Any chance it's magically working? I'm assuming it's not. Yeah, we're also working on making a better validation environment. Back to editor. Let's let this finish running and then I'll show you guys. But what this was supposed to be was me trying out different random optimizations and see what does best. Oh! Is it working? Oh, I'm so happy. Okay, coolsies. It's working. We should still probably switch the thing because having random outages is not fun. Oh, now I'm excited. Okay, cool. I really wasn't in the mood to do something like that. Okay. What were we doing last? We were doing this. Let's keep this as 0.1. We were going to try to just take the max of the gradients. Oh, I'm so excited. Take the max of the gradients and multiply that times the learning rate. I feel like it's an interesting idea. So whichever one, wherever we learn the most, you just take that. Let's run it and let's just make sure all test pass. Cool. Oh, I'm excited. So I'll see how fast that those run test cases went. So we hope to do that a lot more for the rest of the site and have everything run a lot faster. We're working on actually getting that to work, but oh, I'm excited. If this breaks now, it'll be like, thinking about it. I feel like it's gonna break now. Why though? Why break? Why not just work? Let me just see if it's my system or is it OpenML read in MNIST. Let's see if it's just open one of these. Is it me or is it whatever? Is it me? I'm saying, is it DeepML or is it OpenML? Oh, hey, thanks for commenting. Okay, it's not me. Is there any way to get it working? I really just wanted to make my own optimizer. Okay. Data ID 554. Will this work? So just change the data. Yeah, I really do need to change to just using. Okay, no, that's also failed. Okay. This also, it makes me happy that this failed because I would have been really annoyed if. I would have been really annoyed if this worked because then it would just be like, oh, they switched the IDs randomly. Happy, at least if it's broken, let it be broken. Let me see. Yeah, leave, I'm okay. Oh, hey guys. Let's see. Someone commented on YouTube. If people don't see it on the other platforms. Do they not even let it know it's down? They're just like, oh, everything's fine? Okay. I'm a beginner in ML trying to learn properly instead of just copy-pasting tutorials. Any guidance you recommend? I mean, I could easily just DeepML, but I feel like that's a little ingenuous. What is MNC? I don't know what that stands for. But for some trying to learn and actually not just copy paste things, I guess there's a few ways. I mean, the ideal way for me to, my version of learning, you know, how to learn, especially for machine learning, because, I mean, maybe for different fields there's something else better, but I feel like there's a few different main categories. There's problem-based learning, and I'd say that's one main type, and there's understanding-based. Whatever. I'm not sure what MNC stands for. So there's two main types of learning. There's problem-based and there's understanding-based. Oh, my English. Um, I'm sorry about that. I don't know I don't know what to do if my English is hard to understand. Yeah. But there's two main types of learning. There's problem-based learning and there's understanding-based. Problem-based is where you find an interesting problem and um, sorry, just keep on checking chat and let me finish answering this and then I'll check back to chat. There's problem-based learning and there is understanding-based learning. Problem-based learning is where you find an interesting problem. So one example I could give is when I was looking for an engagement ring for my wife, I basically was trying to build a diamond price classifier. So it would look at high quality. I wonder if I could find the data set I was using before. Whatever. Oh, so yeah. It looks at the image of the diamond and tries to predict the price, look, maybe the carat as well. But I guess my main thought was people look at diamonds, so like how these are actually graded, and the grade affects the price a lot, is they look at it and they're like, oh, this looks like it's A grade or B grade or C grade or whatever the actual things are. Please add subtitles. I don't know how to do that right now, to be honest. But in the future, I will definitely add subtitles. I don't think I'm going to do that right now, though. Sorry. But sorry about that. But yeah, in my next streams, I'll add subtitles. So people looked at the diamonds, and they determine, I think it's this, I think it's that. Okay. Which seems like it's not an efficient process, so my idea was to make an algorithm that would look at the image and try and predict the price, maybe take in a few other features. Like, it's hard to tell how big this is from an image, but so include the carats and some other things. So, that would be project-based. Let's say I knew nothing about machine learning, so I would just dive in to a project I find interesting and helpful to myself, try and learn along the way. And this would be more copying, pasting, but sort of trying to... Oh. Hold on, guys. Sorry. My baby is crying. Okay, I'll be back hopefully soon. Sorry. Um, yeah, I sort of gotta go. I feel bad because this is a half answer. I'm probably gonna join back in like 30 minutes. So I'm gonna cancel this and rerun this. I'd say quick answer. I'd say start with problem based, try to find something interesting, copy and paste stuff, build something cool, and then go to the understanding based, which is trying to understand the concepts, like how things work, so you could theoretically improve stuff later. But I'd say start with something you find interesting, build something, and then go to the understanding phase of how things actually work. I'm sorry I have to log off so quickly and so abruptly. I'll hopefully be back on soonish.